Welcome to Chanan Academy. In today's class, we're going to be talking about deductive proof. So, what's a deductive proof? A deductive proof is a logical method used to prove that a mathematical statement is true by using a known fact, definition, axiom, postulates, and previous proven theorem. Now, for example, if we say all humans are mortal. Now, if this is a statement that we have made that all humans are mortal, let us call this statement 1. Statement 1. Let this be the first statement. So let us make another statement. Statement 2. Now, let's say Peter is a human. Now, if Peter is a human and the first statement is true, that all humans are mortal, the second statement is saying that Peter is a human. Because the first statement is correct and then the second statement is stating that Peter is a human, then we conclude that Peter must be a mortal. Because if he's a human and all humans are mortal, then Peter is mortal. So this is what a deductive proof is saying, that it's a logical way or method of proving a statement using a definition or a known fact. Like in this our case, the first statement is a known fact that all humans are mortal. And if Peter is a human, then he must be a mortal. So that's what deductive proof is talking about. Now let us see why we use deductive proof. A deductive proof can help us in various ways in mathematics. One of the ways that deductive proof can help is it helps us verify mathematical statements. Also, it can also help us show that a result is always true. It helps us show that a result is always true. Like in the previous example we gave, that all humans are mortal. So if all humans are mortal, Peter is a human, then anybody who is a human must be a mortal. So it verifies that the result is always true. Okay, so it also helps us to develop logical thinking skills. So to develop logical thinking skills. It also helps us solve geometric and algebra problem accurately. It helps. Number one, it helps verify mathematical statements. Number two, it shows that a result is always true. And number three, it helps us develop logical thinking skills. And number four, it helps solve geometry and algebra problem accurately. Alright, so let's look at some terms used in deductive proof. Key term used in deductive proof. The first one we're going to talk about is statement. Now, a statement is a sentence that is either true or false. It's a sentence that is either true or false. Let's take an example. If I give a statement, let's call that statement statement 1. Statement 1. If I say a triangle has 3 sides. Now, this is a statement. This statement is either true or false. So I want to ask you, is this statement true or false? Of course, the statement is true because every triangle has 3 sides. So this is a triangle, and if you look at the sides are 1, 2, 3. So every triangle has 3 sides. Also, let's make another statement to see. Let's call this statement 2. If I say 2 plus 7 equal 9. Now, this statement is also true because 2 plus 7 is equal 9. So this is what a statement is. A statement is a sentence. It is either the sentence is true or it is false. So that's a statement. Now, a reason is the justification for why a statement is true. The justification for why a statement is true. So, for example, I give a statement. Let's call this statement 1. if I say all square has four sides. Now, if I now tell you that this statement is correct based on what? Now, there must be a justification. The justification that this statement is correct can either be gotten from a definition, a theorem, a postulate, or a property. Now, for this statement, it says all square has four sides. Now, this is a square. From the property of a square, we already know that a square has four sides. 1, 2, 3, 4. So it means that the statement is correct. So it's a justification that a statement that has been made is true by a definition, a theorem, a postulate, or a property. Alright, so let's see the third one. The third one is conclusion. Alright, a conclusion is the final statement being proven. Now let's take example to explain this one. Let's say we have a first statement. Statement 1. Let's call this statement 1. All students in King's College are boys. Now let's say this is a statement and this statement is true. So this is the first statement. Now if we then give the second statement and we say John is a student of King's College. Now this second statement, you reason the second statement using the first statement that is true to get to your conclusion. Alright, if all the students in King's College are boys, now John is a student in King's College. My conclusion is going to be that John is a boy. Even if I do not meet John or I don't know John, I know that as far as John is a student in King's College and all the students in King's College are boys, so it is easy for me to conclude that John is a boy. So that's what conclusion is. It is the final statement being proven. Now, this conclusion is also a statement, but it's a conclusion I have come to, given the previous statement. Alright, so let's check the structure of a deductive proof. The structure of a deductive proof. A deductive proof usually contains a statement and a reason. Now, the first one is given information. Now, this is the information given. So it's given. The second is the logical step. Now, the logical step you can use a definition or a theorem to start to create your logical steps. So a definition or a theorem, and then another logical step. This time you can either use a property, and then you conclude, you make your conclusion, and you've proven it. So the information is given as a statement. Now, then the logical step you're using, try a logical step again, and then with those logical steps and the given information, you then come to a conclusion, and that conclusion is your proof that this statement is true. Alright, so let's talk about types of deductive proof. The first type of deductive proof we are going to talk about is the two-column proof. So the two-column proof contains statement and reason side by side. Let's take an example. Prove that if A, B equal B, C, then B, C equal A, B. Now, this is a statement. You've been asked to prove this. So, in the two-column proof, what we do is place the statement and the reason side by side. So, you put your statement, then you put your reason in a column format. Okay? So, the first statement that was given is A, B equal B, C. Now, this is a statement that was given, so it is given. Now, they said you should prove that B, C is equal A, B. Now, this is the point to do your thinking, your reasoning. And how do you do that? From what we've been shown, we use a definition, a theorem, a postulate, or a property. So from this point, we know that there is a property known as the symmetric property of equality that states that this is correct. The symmetric property of equality. So this is why this statement is correct. And with this, you've proven it. So therefore, this statement has been proven. All right, so let's look at the second type. The paragraph proof is written in sentence. The proof is written in sentence. All right, so let's use the paragraph proof to answer the example we gave above. All right, using the paragraph proof, we are going to put it in a sentence. We are going to say, since AB equal BC, and that's the given information, by the symmetric property, of equality, BC is equal to AB. Therefore, the statement is true. So this is how the paragraph proof is. You put the proof in a sentence. All right, so let's check the next one. The flow proof. Now, the flow proof uses arrow and boxes to show logical connection. So it uses arrows and boxes to show logical connection. So let's try to answer the same question again. Put the first box, AB equal BC, using the symmetric property of equality. So put in a bracket box. All right, it then means that BC is equal to AB. So this is how the flow proof is being presented. All right, so let's look at some important properties used in deductive proof, like the symmetric property. All right, so the first property we are going to talk about is symplectic property. Now, this property says that a quantity is equal to itself. So a quantity is equal to itself. Let's give an example. If we have x, so x is equal to x. There's no difference. If we have, say, 5, 5 is equal to 5. So that's what this property is talking about. All right, so the next property, the symmetric property. Now, the symmetric says that if A is equal to B, then B must be equal to A. Suppose B assume a value of, say, 10. If A is equal to 10, it also means that then 10 is equal to A. So that is what the symmetric property is talking about. All right, so let's go to the next one. The transitive property says that if A is equal to B and B is equal to C, then A must be equal to C. Let's take an example. If A is equal to B and B value of 7, then A is equal to 7. That is what the transitive property is talking about. Okay, so let's look at the next property. Now the next one is the addition property of equality. Now the addition property of equality says if A is equal to B, then A plus C is equal to B plus C. Let's take an example. If A is equal to, then A plus 5 must be equal to 2 plus 5. So this is what the addition property of equality is saying. Since A is 2, so it means that it's the same thing as 2 plus 5. And this is going to give us 7. This also will give us 7. So 7 is equal to 7. So the property is true. Alright, so let's go to the next one. The subtraction property of equality. Subtraction property of equality says that if A is equal B, then A minus C is equal to B minus C. So if A is equal to 2, and it means that A minus 1 is equal to 2 minus 1, and you'll be having 1 equal to 1. So the property is true. Alright, so let's go to the next one, the multiplication property of equality. Now, the multiplication property of equality says if A is equal to B, then A multiplied by C is equal to B multiplied by C. So let's say A is 2. This simply means that A multiplied by 3 is same thing as 2 multiplied by 3. A is 2, so this is going to give us 6, and this is equal to 6. So it's the same thing. The property is true. Okay, let's check the next one. The division property of equality. Now the division property of equality says if A is equal to B, then A over C is equal to B over C. Now, given that C is not equal to 0, and that is because if C is 0, this will be undefined. But if C is not 0, is not equal to 0, this is true. A over B is equal to B over C. Deductive proof in geometry. Alright, so let's take an example to explain this. So if angle A is equal to angle B, prove angle B equal angle A. Now this is the question. We are told that angle A is equal to angle B, and we are asked to prove that angle B is equal to angle A. Solution. Alright, so let's say the statement, the reason. So what's the statement? The first statement is that angle A is equal to angle B, and this is the given statement. Now this is what we are asked to prove. Angle B is equal to angle A. Now the symmetric property tells us that this is correct, so we are going to say, using the symmetric property, so using the symmetric property, this is true. Okay, so let's take another example. Given AB equal to BC and BC equal to CD. Prove AB equal to CD. Alright, so this is what we are given. Alright, so let's try to solve this one. Solution. So let's say statement and the reason. So the first statement that was given is AB equal BC. This statement was given. The next one that was given is BC equal to CD. This was also given. Now we are asked to prove that AB is equal to CD. Now from the property stated above, using the transitive property, this is true. AB will be equal to CD. Alright, deductive proof using algebra. So let's take an example. Given x plus 4 equal 10. Prove that x is equal to 6. Statements, reason. Alright, so we're given x plus 4 equal 10. This is the given information. For us to prove if x is equal to 6, we'll subtract 4 from both sides. So we can have only x. So we have x plus 4. Now we are going to subtract 4 minus 4 equal to 10 minus 4. Now this is the subtraction property. So we are using the subtraction property to see if x is equal to 6. Now if you subtract 4 from the left hand, you're going to have just x on the left hand side. And if you say 10 minus 4, you're going to have 6. So it means that x is actually equal to 6. This is simplification. Alright, hence proved. So it has been proven that x plus 4 equal to 10 if x is equal to 6. Alright, let's move on to steps for solving deductive proof questions. Step for solving deductive proof. The first step you need to do is to write down the given information. Step 2, identify what must be proved. The next step is step 3. Use definition, property, or theorem. Alright, so the next one, show each logical step clearly. Step 5, you reach your conclusion if the statement is true or false. So these are the 5 steps for solving deductive proof question. The first thing you do is to write down the given information. Then you identify what you are asked to prove. Then you use definition, properties, or theorem to make your reason and show the logical step clearly, and then you reach your conclusion. Alright, so we've come to the end of the class. Thank you for watching till this time. Please do not forget to subscribe, and please drop your answer to this question in the comment section. Bye for now.